right, in this session, let's just take a look at application of the triangle rules on bearing and navigation. All right. I will start by just discussing a few terms that we use in this area, and that is first of all, what we mean by bearing. All right. So what we have here is a compass, needle, if you may, and you know, with the north, south, east, and west as usual. All right. We will usually be at the center of the compass needle. Now, unlike in the other parts of trigonometry, like the unit circle, where this is usually the 0, and we count the angles in the anti-clockwise direction. So if this is 0, that is 90 degrees, that is 180, 270, and 360. In the case of bearing, also sometimes called true bearing, we make the north be our 0. So you can see that the 360 or the 0 is up here. And secondly, we count in the clockwise direction. All right? So if we are in this position, if we are at the center at this point, then we can, and let's say a point is somewhere there, we can measure how far this or the angle of that point from the true north. Okay? So for example, that's the pointer indicating that the bearing of anything in this direction will be on a bearing of 0, 000, right? So the bearing there would be 0, 0, 0. An object that is, let's say, somewhere there from the true north, so that appears to be 40 degrees, we will refer to the bearing of that point as 040. So it might be 5 kilometers on a bearing of 040 from where we are standing. So we would be standing there at the center of the compass needle. All right? And another example is a point that is in this direction would be on a bearing, this in particular, this one would be 120, I believe. So that's a bearing of 120. Another example there is a bearing of 230, and a point that is that way would be on a bearing of 330 degrees. So we measure the angle from the true north, which would be this one here. So every direction of an object from where we are standing would be measured from true north, and we will measure in the clockwise direction. So in true bearing, we measure in the clockwise direction, and we start from the true north as our 0. In the unit circle, where we discuss the rest of the trigonometry, our 0 is usually here, okay, where the east is, and we measure angles in the anti-clockwise, or as Americans say, counterclockwise direction. All right? So let's look at bearing using a typical question. All right? So here's an example. A ship at port P sails on a bearing of 030 to port Q, which is 80 kilometers away. It turns and sails directly to port R, which is 100 kilometers in a bearing of 150 from Q. So it's important the bearing is measured from where, right? So this time it is from Q. Show this information on a diagram. Find angle PQR, all right? How far is port R from port P? And what is the bearing of port R from P, port P from R, and port P from Q? So by answering this question, we will have discussed some of the language used in bearing. So let's just take a look. The first part of the question wants us to show the information on a diagram. So a ship is at point P, so we go and make a point P there. All right, so that's going to be my point P. All right, well, let's label it P. And point P is on a bearing of 030. All right, it is sailing on a bearing of 030 towards point Q. That means point Q is on a bearing of 030. To do that, we will place the compass needle there. There's my compass needle. And I will mark a true north there. So that will represent my true north, and all angles will be measured from true north, okay? So we want 0, 30. So an angle of 0, 30 there to point Q, and point Q is a distance of 80 kilometers away, all right? So we have shown point Q on a bearing of 0, 30. So that's 30 degrees there, okay? It turns and sails directly to another port, R, which is 100 kilometers on a bearing of 150, but this time it is from Q. So that means we will be measuring 150 standing here. That means we have to bring our compass needle to this point, okay, and measure that 150 from there, all right? So we place our compass needle there and create our true north up there, so that's that dotted line there, and we measure an angle of 150 degrees, okay, 100 kilometers to a new point on a bearing of from Q. So it's going to point R, so this is going to be our point R at the end there. Here is the diagram that we are being asked to draw, okay? So this is a diagram you will be expected to be able to draw. It should not be very difficult. Part 2, I think, is asking us to find the angle PQR. So what angle PQR? PQR is referring to this angle here, but this angle is made up of this part and that part. Well, this line means we have an angle of 180 up to this point. And since this is already 150, it means whatever is remaining there has to be 30 degrees. And similarly, all right, so this angle here has to be 30, okay? Now on this side, this dotted line and that dotted line are parallel. If you join them by a straight line, then this angle here, 30 degrees here, and that angle there are called alternate angles, okay, from basic angles. So it means alternate angles are equal, and that means this angle here is 30 degrees, okay? So this is 30 degrees, and this is also 30 degrees, which means the whole angle there has to be 60 degrees, okay? So PQR is 30 from here, and 30 from there, which makes it 60 degrees, okay? Part C, how far is port R from port P? How far is R now from P? That means we are looking for this distance here. We can represent that distance by a line there and call it X, okay? Since we know this angle here to be 60 degrees, we just found it earlier. Since we know that angle and we know the sides that form it, okay, the forming sides, that angle becomes the included angle for the side 80 kilometers and 100 kilometers. So we can use cosine rule to find the distance X, and let's reason now. So using cosine rule, A squared is B squared plus C squared minus 2BC cosine of A. That means that our X squared must be 80 squared plus 100 squared minus twice 80 times 100 cosine of 60. Let me write that down. Okay, so 30 squared is 900. 100 squared is 10,000. So 10,900 minus cosine of 60 is a half. So a half times that is 300. So 10,900 minus 300 should be 7,900, and when we look for the square root of that, we find the distance to be 88.9, approximately 88.9 kilometers. So X there is 88.9 via that calculator, okay? Part D, what is the bearing of port R from P? Okay, the key word here is the use of this word from. So when it says from P, from R, from Q, that means we go and stand at P or stand at Q or stand at R, right? So if we're looking for, we want to find R from P, we go to P. and we are looking for, so we want to know the bearing. Where is this? What's the angle measured from? We are at P, so this is our true north at P. We want to know this angle here all the way up to that. That becomes the bearing of R from P. Okay, the bearing of P from R means now we go to R and we want to know where P is. So we are going to have to rotate all the way until we have that. So what is that angle? Okay, to indicate the bearing of R of P from R. And similarly, we'll find the bearing of P from Q. So if we are at Q, how far is P in terms of angle? So we stand there and we rotate this all the way until that. So we need to know what that angle is for bearing, okay? Let's do that quickly. Right? So we know the angle there as 60, okay? And we know that. We know the distances. We also know this distance now, it's 88.9 kilometers. So if we are going to find the bearing of R from P, we want to know where this is, meaning we want to know this angle here, all the way up to this angle here. To do that, we need to know angle P. Okay, this angle here is angle P. We need to know that. And the best way to find that is, of course, the sine rule. You can try and use the cosine rule, which also works, because 100 squared is 80 squared plus 88.9 squared minus twice times this, cosine of that angle we are looking for. So you can make cosine the subject of the formula and find it. I leave that to you to do as an exercise and confirm the result we are going to get using the sine rule. So if we use the sine rule, what do we have? We get that the sine of this angle P divided by 100 must be the sine of 60, angle 60, divided by 88.9, okay? We can't use this because we still don't know it, so we can't use 80 and the angle opposite it. So using that, make P the subject of the formula, we get that P is, maybe I should write this here before I do this. Yeah, make sine P subject, we have sine of P is equal to 100 sine of 60, everything divided by 88.9, right? And so P becomes sine inverse of this thing in bracket, okay? That's what we are doing. So when we do that, what do we get? All right, so what do we get? So make P the subject, we get sine inverse of that, which gives us a value of P of 77 degrees. So we know that that angle there is 77 degrees. Okay, with that knowledge, we can now find this other angle as well. Okay, therefore the bearing of, so let's just go on and answer this question. The bearing of P, of R from P, where is R from P? What's the bearing? We are looking for that angle there. Well, that is 30 and that is 77 that we found, and therefore the bearing has to be 77 plus 30, which is 107. Okay? Part B is what's the bearing of P from R. So now we go to R. So we place our compass at R there, place the compass there. So what we are looking for is the bearing of P from here. So that means this is our true north here, and we want the whole angle all the way to that point, okay? Well, to do that, we need to know this angle here, and we know it because by alternate angle rule, that dotted line is parallel to this dotted line. So this we found earlier was 30. Since this is 150, this here was 30. And if this is 30, then this has also got to be 30, right? So this angle there is 30. That's the angle we are looking for, but we know that is 30. Also, this is 60, and that is 77. So when we add that, we get 137, and sum of interior angles of a triangle is 180. So 180 minus 137 should be 43 degrees. If we add these two, we get 73 degrees. So therefore, our angle there has to be 360 minus 73 degrees. Okay, so 360 minus 73 degrees, which gives us, I think, 289 degrees. So the bearing of P from R is 289. Okay, lastly, we want the bearing of P from Q. So now we are at Q, we want the bearing of P. The bearing of P has to be that angle all the way up to that, and I don't need to do any additional calculation because this bit is 60 and this is 150. So all the way from there to the line going to P must be 150 plus 60 degrees, and that gives me 210 degrees for the bearing of P from Q. I hope this is making sense. Write in the comment if you need any additional explanation, but otherwise this is as easy as it looks, right? Here is some examples I want you to try. Problem number 2, a ship is sailing due north, blah, blah, blah. First thing is, of course, to draw a diagram like the one that we did, and then answer the question, okay? So problem number 2 is for you to try. Problem number 3 is another one for you to try. This is an exam style question, but it's really, it's not anything that would be HL. This is more likely SL and MYP5 kind of material. Here is another one, an exam type question. All right, just pause the video and solve it, and let's see what you get. Once again, in 2 or 3 days, I'm going to put the solutions of this in the discussion below. So try it and then check what you get out of it. Here's another one. This has less to do with bearing really, but other terms that we use in trigonometry, like when we say the angle of depression or angle of elevation. What does it mean? So the angle of depression here means that you have a horizontal and you depress this horizontal like that, so that we make an angle of 28. So this would be referred to as an angle of depression. On the other hand, a person on the ship here would be looking up, and we would say that this angle here would be an angle of elevation because you are raising. So when you're raising, we use the term elevation. So we would say that the angle of elevation here would be 28, again because of alternate angles. So if that is to this line here is parallel to the ground or the sea, and therefore if you join this with a straight line, this angle must be equal to that angle, alternate angle. So we can say the angle of elevation of the base D there, the base of the lighthouse, the angle of elevation of the base from the ship is 28, just like the angle of depression of the ship from the base of the tower, all right, of the lighthouse is also 28, like that. So try that out and let's see what you get. You're still using trigonometric laws to solve this problem, all right? Okay, that brings us to the end of our discussion on bearings. Let me know what you think. Thank you for watching the video. If you like it, please subscribe and like the video so that you will be able to be notified when subsequent videos come up. Thank you very much.